Greetings, my name is Ahmad Fazrin bin Majohat and I'm from Group 8. Me and my group members will be present in this video about the calculation of the maximum torque, the maximum engine efficiency and the BSFC, the brake specific fuel consumption. From the engine spec and the calculation, we will also be able to get the maximum pressure analysis, the peak pressure using the formulate Microsoft Excel given. Our group chose 2JZ GTE Toyota Supra engine for this assignment. We have been research and do the calculation for the engine specification and we get the compression ratio is equal to 8.5, the piston displacement for 99.6 cm3, the piston cylinder bore and also the length of the piston stroke is 8.6 cm, the length of piston rod 14.2 cm, and the air fuel ratio AFR 14.8. All of this specification has been updated in the formulate Microsoft Excel given, and here the value that we got. The value of this displacement VC was obtained through the theoretical calculation as shown here. The VC is equal to the stroke times piston area, and we got 4.9956 times 10 to the negative 4 meter cube. Other than the state value here, all kept constant and some are modified automatically by the Microsoft Excel due to the formulate embedded in this file to form the PV diagram graph.
Hi everyone, my name is Muhammad Arif bin Muhammad Azhali. My metric number is MH19080. So I will continue with the PV diagram. So we can see from here that PV diagram is actually auto cycle PV diagram. So what is behind the auto cycle? The auto cycle is the operation of standard spark ignition piston engine, which is we know as petrol engine. Alright, now we can see the PV diagram. There are 4 processes that involve in the auto cycle. Let's go one by one. The first one is involve the charge being compressed adiabatically, which is isentropically, as the piston advances from bottom dead center to the top dead center. Next, we move to the process number 2 to the number 3. Is a constant volume heat transfer from an external source to the working gas while the piston is at the top dead center. This procedure is meant to simulate the ignition of the fuel air mixture and subsequent repeat burning. Then we have the process 3 to 4, which is isentropic adiabatically explosion, which is we know as power stroke. And for the last process 4 to 1, which is complete the cycle with a constant volume process that reject heat from the air while the piston is at the bottom dead center. Alright, now we have the actual of PV diagram for our engine, and just now I just show the ideal type of PV diagram from auto cycle. So we gain this graph from the input of volume clearance, which is VC, and we can see that we want to find the peak of the pressure, which is the maximum pressure of our engine. And why we want the value of the peak of our engine? Because it really important we can know the higher pressure of the cylinder, and then we know the higher force in the crankshaft, and the last one we can know the higher output torque. From the peak pressure value, we can calculate a few things around our engine. So from our data, we gain the peak pressure value is 81.6342 atm.
So for the next part, we will move on to the torque value of the 2JZ GT engine. This engine produces one of the highest torque value to its wheelbase. So now let's start with the definition of torque. So torque can be regarded as the turning force applied on an object. In this case, the object is the piston, and the distance between the turning point, which is the crankshaft, and the piston is known as the lever arm. So from here we can find the value of torque with the cross product of force applied on top of the piston and multiplied with the distance scalar of the connecting rod. Now in order to find the torque, we need to use area first. we need to find area first, the area of the piston bore. So we use the formula pi times b square over 4, and then once we gain the value of the area of the piston, we use that to find the force. So force is pressure times area, so we need to find the pressure we obtain from the Excel analysis, where we put all the values and specifications of the engine, and then we obtain the value of the force. So we got around 81.63 atm has the highest peak pressure obtained from the engine, and then I converted it into Pascal. So we get around 82,715 Pascal. So from here we can find the value of force by multiplying with the area of the piston, and then moving on to the total torque, force times R, which is the length of the rod. We find that the torque is 406 Newton per meter, which is considerably higher compared to the general cars. So with this amount of force, Toyota can produce a lot of power.
Okay, for my part, I will explain about the mean effective pressure, MEP. The mean effective pressure is a theoretical parameter used to measure the performance of an internal combustion engine. Even if it contains the word pressure, it's not an actual pressure measurement within the engine cylinder. The cylinder pressure in an ICE is continuously changing during the combustion cycle. The figure below shows where the mean effective pressure is located in the PV graph diagram. The mean effective pressure can be regarded as an average pressure in the cylinder for a complete cycle engine. By definition, mean effective pressure is a ratio between the work and engine displacement. Okay, for our engine, which is a multiple cylinder, so we have to take into account the total volumetric capacity. For NC being the number of cylinders, the expression of mean effective pressure becomes 2 pi times number of crankshaft rotation for a complete engine cycle, which is 2 times maximum torque divided by engine displacement times number of cylinder, which is 6, and we get the mean effective pressure 1704,689.032 Pascal. Mean effective pressure is used for initial engine design calculation. With engine torque and MEP as input, the engine designer can calculate what is the required engine volumetric capacity. Remember that the mean effective pressure is only a parameter to measure engine performance and does not reflect the actual pressure inside an individual combustion chamber. Thank you.
Good day to our lecturer, Dr. Devarajan. Today I'm going to present on the engine effective brake power and engine efficiency of the 2JZ GTE Toyota engine. So for the engine effective brake power, the product of the torque, which is Newton meter unit, and angular velocity radian per second unit, is equal to the power, which is the rate of doing work in the rotational system. Revolution per minute of the 2JZ GTE Toyota engine when power is maximum, which is 5600 revolution per minute. The effective torsional force is 406.6064 Newton meter. Hence, the calculation of maximum power of the engine at the specific revolution per minute is brake power equals to 2 pi times multiplied by revolution of engine multiplied by effective torque. So the value for the brake power is 238.446 kilowatt. As for the engine efficiency, by assuming that 720 grams of gasoline are consumed per minute at full load, gasoline has a combustion value of 4.6 times 10 to the power of 7 joules per kilogram. So for the engine efficiency, the calculation is equals to power times time over over um, over the mass multiplied by combustion value of 4.6 times 10 to the power of 7 multiplied by 100 percentage. So the final value for the engine efficiency is 43%.
My name is Muhammad Omar Hakim Padil. Matrix number is MH20020. Now I will explain about BSFC, that is brake specific fuel consumption. Brake specific fuel consumption is a parameter that reflects the efficiency of a combustion engine which burns fuel and produces rotational power at the shaft or crankshaft. In automotive application, BSFC is used to evaluate the efficiency of the internal combustion engine. The formula for BSFC is BSFC equal to flow rate of fuel over rate of power. For our engine, BSFC equal to 1.51 GWS over 238.446 kW times 3600. BFSC is equal to 22.7976 G over kWh. So the conclusion from the assessment, we were able to study the capacity and efficiency of 2JZ engine at its ideal condition. One of the results of the experiment is that the engine has powerful output, but the efficiency of its consumption is lower, which might be a real challenge for the continuous usage of the engine. That's all from us. Thank you.